In this video, we are going to discuss the pseudocode as well as the code in C++ for the merge sort algorithm. So here we have the pseudocode, and the pseudocode is generally divided into two different components. First is our core merge sort algorithm. The second one is the merge function in the merge sort algorithm, which is used to combine two different lists. This merge function is actually the core or the central idea that we can sort two lists which are already sorted in O of n time. So let's see the code for merge sort. So as an input to our merge sort, we are always going to provide our array, our start index, which is going to be 0 by default, and the size that's being provided to the array. Next, as our base case for our recursion, we are going to check the condition that start is less than end. And why we are performing this is because, like, let's say if we have just an array of size 1, in that case, what will happen is we'll have 0 here, and the length will be actually equal to 1 minus 1, which is 0. So this condition will never be fulfilled. And we are going to ignore all the statements in the loop. And why that's necessary is because an array of size 1 is already sorted. So we need some base case to stop our algorithm. Next, we compute the middle element by summing up the start plus n divided by 2. Next, we are going to call, let's say if our array looks like this, we are now going to repeatedly call the merge sort on the left half and the right half. So here we compute the middle element. So let's say our middle is right here, and middle is equal to start plus n divided by 2. And since it's it's taking integers, this will actually be equal to floor. Like if you want, you can write floor of the start plus n divided by 2. Next, we are going to call merge sort on numbers start comma middle and numbers middle plus 1 comma end, which is this might be from 0 to m, and this will be something like m plus 1 to end. Once we are done breaking this problem into smaller halves, in the end we are going to call our merge function, which is going to combine these two lists into one list which is sorted. So how this is going to work is let's take a very small example, which is, let's say we just have two numbers in our array. That might look something like this, which is we have two numbers, 3 and 1. These are not sorted. So how it's going to work is our array will be a 0, and the length would be something like, since it's 2, so it will be 1. Now, since start here 0 is less than 1, what we are going to do is we are going to compute the middle, which is 0 plus 1, which is 1 divided by 2 is 0, because we are taking the floor. Next, we are going to call merge sort with our initial array, which is called numbers, and with the start index, which is 0, and with the middle index, which is 0. Once it goes back up, now start is not less than end because both of them are equal, so nothing will be actually computed. Okay. Next, we are going to call merge sort on the array with middle plus 1. So middle plus 1 of our previous recursive call was 0 because we still haven't computed finishing this second part. So in this case, it will be 1, and the end is going to be 1 as well. Next, when you call merge sort on array 1, 1, it will go back up. Now start is not less than end because both of them are equal. So what it's going to do is we have finished computing both these merge sorts of the smaller halves, because technically each of these left and right halves are of size 1, which are already sorted. Next, we are going to call the merge algorithm or the merge function of our pseudocode, which is merge. We are going to call it on the numbers array, which is a. Start, initially, like when we had size of 2, our start was something like 0. End, when we provided to the algorithm, was 1. And middle was 0, because we still haven't finished the execution of the first recursive call, because the other ones are already complete now, because once we compute these two recursive calls, there's nothing to be computed. We have already exited this if statements, and we are going to go back to the parent recursion. So in that case, it's going to send this array with position 001 to our merge algorithm. So in this case, it is the merge pseudocode. So I'm not going to show you like how it's merging, but we have already discussed this earlier, and then I'm going to also discuss this when we discuss the actual C++ code. So what it's going to do is we have arrays access with start 0. I'm so sorry. We have start 0, end is 1, and middle is also 0. So we have start, middle, and end. Now it's going to keep a track of the both the starting positions of the two sub arrays, because we know the left half, which is the array on the left has is going to be from S to M. So in this case, there's one element, so you will not have difficulty in conceptualizing it. But if there were more elements, the left array would be from S to M, and the right array would be from M plus 1 to E. So in this case, we have two arrays, which are 3 and 1. And next, what we are going to do is we are going to repeatedly compare till we reach the end of the array. So in this case, 3 is compared to 1. And now we are going to compare, like add the smaller item to a new array of size 2. So in this case, 1 is smaller, we are going to add it. Next, we are going to change the current item's iterator to the next one. So we are going to move this here. And we are checking like whether we have reached end of the sequence of another one. So in this case, we'll exit out of this while loop. Our array still has just 1. We still don't have third, because we have finished iterating over one of the arrays, which are 1. Now we are going to copy any remaining arrays from first sequence or second sequence into the array. So in this case, the first sequence still has some values, like right here. So we are going to add that to the array, and we are going to return back to our function. So at the end of the function, like our 3-1 is now sorted to 1-3. And similarly, like with each recursive call, we are going to combine these using the merge step. So this was a very small example of two numbers. I was just showing you like how the recursion is taking place, which is at the most elementary level. This combination is going to take place. And then for the other recursive calls, like let's say if we had 4 values, these two lists, which is this side and the left and right side, will be computed after we have finished solving the smaller bits. So let's see the C++ code for the merge sort. Again, we have this merge function that takes in the left and right. In our earlier case, we had start and end, so it's left and right. We are checking whether left is less than right. Then we compute the middle element, which is left plus r minus 1 divided by 2. You can just take L plus r divided by 2. Either of them is the same, and take the floor of it. You'll get the same results. You do the merge sort from L to M, which is from the starting point to the middle point. And you call the second merge sort on the right half, which is middle plus 1 and right, or that's the end point. Next, we are going to call our merge function with the values left, middle, and right. So let's I have already I have this code on this link. So if anybody is interested, they can click on this and see how to write the driver function. And the driver function will typically call this value, which is merge sort array 0 and the size of the array minus 1. Also, they are the second half of the algorithm is the merge step. So this is the more tricky code. What you are going to do is you have the left, middle, and right indices. First, you are going to create two arrays. The first array will store the left half, which is from L to M. So I'm calling this X. The right array is called Y, which is storing from M plus 1 to R. So the sizes of this array can be computed by, you can just subtract M minus L plus 1. So that's going to give you the size of the first array, which is X. And if you do like R minus M, that's going to give you the size of the second array. So you have to create these arrays to sort the numbers. There's no way you can sort, like merge these two lists in the same list itself. Like there's no way to do that. So you will need some additional memory. And this is where we are having like additional ON memory space that we require. Next, in the first left array, you are going to copy all the numbers of our initial array from 0 to n minus n1. Next, you are copying all the numbers in the array from the middle position to the end position in this yj array. Now what we are going to do is we are going to merge these two arrays. So we are checking if we have reached the end of either of the arrays. If the element is less than, like if let's say if we have two arrays that look something like this, we have 5, 2, 1 and 13. So like let's take 12 because they have to be sorted. So what we are trying to do is we are checking the value at this xi is less than the value at yi. If that's the case, in this new array or in the original array, because now we have already defined a new array which has these two subcomponents, you can actually, instead of moving these values in the original array, you can move, like you can create the new arrays and store them. And instead, in that case, you do not have to do this step. Like there's another way to do it, but let's stick to this one. So what we are going to do is we are going to place in our new array the lower of these two values. So we are going to place 1 and we are going to add I, which was initially 0. Now it will be 1. Next, it will go back up. It will see that 5 is actually, like we still haven't reached the end of the array. So it's going to compare 5 with this value 13. So since 5 is smaller, it will actually add to the array, like in our new array, it would look something like this, which is 1, 5, and move the pointer in the first array, which is now like this is called J or something like that. So we are moving that pointer. And next it's going to go back up and repeat the process till we have reached the end of the list. So in this case, 12 will be added and we have reached the end of this list. So we have completed doing that. So now we are going to add the remaining elements into the array, which is, since this list is already empty, we will not enter this loop, but this loop will still be entered to add whatever value we have in the second array. So we have this code to ensure whatever has not been traversed in the one of the arrays which have not been completed, we are just going to append that to our array, the initial array. We are just going to override those values because we still have copies of the values in X and Y. So this was the code for merge sort. I can, like, if anybody has difficulties, I can go over this with a small example. I can actually do it right now. Maybe like, let's do one small example. So for those of you who have already understood this, you can stop this video and it's fine. I can just discuss the complexity and I'll go back to an example. So the worst case complexity will be O of n log n. Again, like when we were discussing this tree, at each iteration, we are doing n amounts of work, because this would be like n work. This will be n by 2 plus n by 2. This will be n by 4 plus like n by 4. Or technically it will be like 2/3, but let's say if it was, for consistency, if this was an even list, which was like this had 8 elements, then it would be n by 4 plus n by 4 plus n by 4 plus n by 4. So at each level of the recursion, we are basically performing n times of work. So it will be like n, n, n. And if you see that the height of the recursion tree, it's going to be log n because we are dividing the tree into halves. So the total complexity will be n log n. So again, like going back to the merge sort time complexity, in the worst case, it's going to be O of n log n. In the average case and the best case also, it's going to be n log n because that's the best we can do when we are dealing with merge sort. Now the space will be O of n, which is we need some more space or some auxiliary space to solve this problem. Like when we discuss like selection and the other types of sorts, the basic sorts, we didn't require extra space. So now we need additional space in our memory to solve these problems. So I'm going to end this video by taking a very small example of a small array and show you like how the recursions are working.